This is the Honors Pre-Calculus Final Exam Review. We're looking at number 8, 9, and 10. It says to give the exact value of these functions. We want to focus in on this word exact because you may have a calculator to do this exam, but your calculator will not give you the exact value. It will give you a decimal value which is approximate, and that will be counted wrong because for the exact value, what it really is asking us is, do you remember the unit circle well enough that you can tell me this cotangent of 120 degrees without looking at it? So, and you also will not be permitted a unit circle or any notes on the test, so you need to know the unit circle and know what are the values on the unit circle. So we are asked for cotangent of 120 degrees. Cotangent of 120 degrees. The first thing we need to know is where is 120 degrees on the unit circle? What are the sine, cosine, and tangent? What information can we get about it? Here's 90 degrees, and of course for our unit circle we might be more accustomed to thinking in terms of radians, but we should be able to do both. So 120 degrees is here, and this is 135 degrees. I didn't memorize that this is 135 degrees. I just know that this is 90 degrees, and if I add 45 degrees, it's going to be 135 here. And if I add 60 degrees, I'm going to have 150 degrees here. Now I need to know the cotangent of 120 degrees. So that means there are a couple of ways I can approach that. One is I can just know the sines and cosines. And if I know the sine and cosine at 120 degrees, then I can get this cotangent. If I look at 120 degrees and look at what are the coordinates of that point. So I need to know somehow or another that the x-coordinate here is negative, and this x-coordinate is negative 1/2, and the y-coordinate is positive, and it's positive square root 3 over 2. So I now know that the sine of 120 degrees, the sine is the y-coordinate. So you want to remember that the sine is the y-coordinate. That's the sine. And the x-coordinate is the cosine. So this x-coordinate is the cosine. So our sine of 120 degrees is square root 3 over 2. And our cosine of 120 degrees is negative 1/2. And we know that just because we know the unit circle. Then we want cotangent. So what I need to know about cotangent, we need to know a couple things about cotangent. We need to know that cotangent is 1 over tangent, and we need to know that tangent is sine over cosine. Now since tangent is sine over cosine and cotangent is 1 over tangent, it follows that cotangent must be cosine over sine. And since cotangent of 120 degrees equals cosine of 120 degrees over sine of 120 degrees, and I know from my unit circle that the cosine of 120 degrees is negative 1/2, and the sine of 120 degrees is square root 3 over 2, then I have this complex fraction. What I need to do is take the denominator and do the reciprocal of the denominator and then multiply. So I'm going to keep this negative 1/2, and then I'm going to go times 2 over square root 3. So I've taken this square root 3 over 2 and flipped it over. I should look to see if I can reduce anything. In fact, I can reduce these 2's, and then I get negative 1 over square root 3. But negative 1 over square root 3 is not an acceptable answer because we have a radical in the denominator. So what we're going to do is rationalize the denominator by multiplying the top and bottom by square root 3. We want to make sure that we don't lose our negative sign as we go along, so there's the negative. 1 times square root 3 is square root 3, and square root 3 times square root 3 is 3. So there's our cotangent. It's negative square root 3 over 3. So this was a lot of work to get the cotangent just from knowing that sine and cosine of 120 degrees because we know our unit circle. And the closest we can have to a shortcut is that a lot of people, along with the way they remember the unit circle, will also remember the tangents. So if we remember the tangents going around the unit circle, the tangents go 0, root 3 over 3, 1, root 3, undefined. So this tangent is negative root 3, this one's negative 1, and this one's negative root 3 over 3, and this tangent is 0. So what I've put in red are the tangents. And if you remember those tangents, it makes this work a lot easier, because then you can just say, oh, I know at 120 degrees, the tangent is negative square root 3. Then I can just say, since cotangent is 1 over tangent, I can say that tangent of 120 degrees is equal to negative square root 3. Therefore, cotangent of 120 degrees must be 1 over negative square root 3, which brings me to here, so that I must also rationalize the denominator again. Square root 3 over square root 3. It doesn't matter that this negative is in the denominator. I'll just pull it out to the front of the fraction. And then 1 times square root 3 is square root 3. And square root 3 times square root 3 is 3. So I get my tangent of 120 degrees is negative square root 3 over 3. So we're going to answer number 9 and 10 the same way. It just means that you have to know the unit circle. But I also have to know something about secant and cosecant. I have to know for number 9 that secant theta is equal to 1 over cosine theta. And for number 10, I need to know that cosecant theta is equal to 1 over sine theta. So if I want secant of 240 degrees for number 9, I need to know that that's 1 over the cosine of 240 degrees. So I just need to find 240 degrees on the unit circle. This is 270 degrees down here. I need to know where everything is. If I want to know what this angle is here, I take my 180 and add 45 to it. So here's 225 degrees. If I take 180 and add 30, I get 210 degrees. And if I take 180 and add 60, I get 240 degrees. That's the angle that I'm interested in. And now I'm going to look at the coordinates of that point. And the coordinates at 240 degrees, well, and again, we just have to know, well, they're the same. It's the same x-coordinate as this one. That's an x-coordinate negative 1/2. And my y-coordinate now is also negative, and it's down here, so it's negative square root 3 over 2. So this is my sine, and my cosine. And since I want cosine of 240 degrees, I want negative 1/2 to be down here. So we're going to say that's 1 over negative 1/2, and that's equal to negative 2. And for number 10, we have cosecant is 1 over sine. And we need, so that means that our cosecant of 330 degrees, cosecant of 330 degrees is equal to 1 over sine 330 degrees. And we need to know where 330 degrees is. So here's 270. If I add 30, I get 300 degrees. If I add 45, I get 315 degrees. And if I add 60, I get 330 degrees. And I need to know the coordinates of that point. So this time it's the x-coordinate that's square root 3 over 2. So the x-coordinate is square root 3 over 2. The y-coordinate is negative. That's negative 1/2. And we just need to know those coordinates because we studied the unit circle and we know them. And so we need the sine of 330 degrees. That's the y-coordinate. So this is equal to 1 over negative 1/2. And that's also negative 2. And that's how we're getting our exact values for cotangent, secant, and cosecant. We need to know the unit circle. We need to know all the values on the unit circle everywhere. And we need to know some basic identities about cotangent, tangent, secant, and cosecant.